Start recording. All right, so everything from here on will be recorded. And then let's go to the Canvas page for this class. So let me put it here. There we go. All right. So a few things that are important. The first one is the recording on Monday is about the practice exam. I explained, the answers, to the practice exam and any questions that was asked during that time. So if you have not watched the recording on Monday, you might want to consider doing that as soon as possible because it is related to your first exam, which is next Monday. All right. Does everybody know where to find the video recording for this class? All right, cool. All right, so I just want to make sure that whether you watch it or not is your choice, not because I did not tell you where to find it. All right, so now that you have that choice, you can make that choice. You can choose whether to do it or not. So what we'll do today, the first thing is to take a look at the homework assignment that was due 2 minutes, 3 minutes ago, just so that we can take a look, make sure that you understand the concepts. If you're not getting the homework assignment done correctly, or it's totally like not what I would be describing, it's not too big of a deal because all the homework assignments add up to 20% of all the score that you need, for this class. So that means missing one entire homework assignment is not going to hurt too badly. But in the process of understanding, why the homework assignment is not done the way that I do it in class, understanding that is really important, okay? Because that allows you to answer the questions correctly in the exam. So that would be the value of going through the homework assignment. So let's go ahead and do it. Let me navigate to the homework assignment, and then we'll just kind of do it as if it is a new homework assignment to me, and this is about nested control. So we have nested trace here. Open a new tab, and let me close the other tabs that are not really useful at this point. Okay, so that's not useful. All right, so this is your homework assignment. I gave you an algorithm, and your job is to trace it. Okay, so what I'll do is I'm going to do the usual thing that I do, which is, okay, not that. All right, one more time. There we go. All right, so I'm going to put it in its own window, and then I'll go ahead and trace it in a Google Sheet that you guys can refer to. All right, so move this to a corner of the screen, go to the shared folder for this class, start a new sheet. So this way, you have access to the sheet as I work on it. So that means if you're using a laptop computer right now, or if you use the computer that is in the desk, or you pull it out, you can actually take a look at the document as we go. So that hopefully that can be useful for some people. So I'll just name it after today's date, which is the 24th of December. There we go. All right. Do we have any questions to begin with this code? Nope. No questions? All right. So we'll go ahead and look at the columns that we typically would need. At this point of time, I will still put line number in column A, but if you put it in some other columns, that will be fine. Okay, I'm not going to take points off because you put your line number at some other columns. In this case, we only have one single variable, which is x in this case. So we have one single variable x, and then we have the comments column just so that we can document when we have to evaluate conditions. So here we go. So this is the general format of your trace. Okay. Now, as I do this, I'm also expecting people to kind of create the heading and also edit the document in a similar fashion. Okay. So if your order of editing is close, but not exactly like this, you go like, darn it, I forgot about this, and you have to insert a column. That is not a problem. What I'll be looking for would be people who just do a copy and paste, into the document, or somehow the order of entering the cells is not does not make sense to me. So I'll be looking out for those things. All right, so we'll start with a precondition. The precondition has to say something about x. Okay, do we know anything about x, or does it even make sense to have a particular known value for x? In this case, the first thing we do in this code here is to overwrite the value of x with a constant of 5, which does not even depend on the old value of x. So it would not make sense for us to have any precondition for x, because any type of precondition for x would not make any sense. Okay, it would just be overwritten on line 1. So now we move on to line 1. The only thing it's going to do is to change x to 5. Move on to line 2. Line 2 is evaluating x does not equal to 0. And is that true or false? It is true. Okay, there we go. And when the condition of a while loop is true, we go into the body of the while loop, which in this case consists of line 3 all the way to line 5. Okay, so that would be the content of the outer loop. So we go to line 3. Line 3 says, oh, let's add 7 to x. So now, instead of just, entering 12, let me give you another thing that you can do also, is you can refer to the current value of x and then just say, add 7 to it. So what I'm doing here is I'm using the formula feature of a spreadsheet just so that I don't have to do the actual calculation of what is 5 plus 7. Okay, now do you have to do this? Am I going to grade your submission based on, oh, do you know all the tricks about using a spreadsheet? The answer is no. Okay, you just type tab 12 in the cell and you'll be fine. Okay, but I'm showing you, this because a spreadsheet is actually a really useful tool, not only in this class for tracing algorithms, but generally speaking, it is a very useful tool for a lot of different things. Okay, so I just want you to kind of know about the ability of a spreadsheet. Okay, so now we get to line 4. Line 4 is a while statement with a condition, which means we have to evaluate the condition. X is greater than or equal to 5 is true. Okay, so we'll say that is true. Then we get to the body of the loop, which is on line 5. And then we subtract 5 from x, it becomes 7. So once again, I can oops, that's not what I wanted to type. So I will just go like, okay, take this value and then subtract 5 from it, and it would become the new value of x. So it's a pretty handy feature when you have longer and more complicated things to compute. For something simple like this, obviously you don't need to use that feature. All right. So this is a good place to ask the question, where do we go next? Line 4, very good. Okay, so we are understanding the concept of nesting. So now we go back to line 4, which is asking the question of is x greater than 5? It is still true because 7 is greater than or equal to 5. So now we go back to line 5 again, and I'll just do the same trick here. Okay, we'll take, oops, there we go. So we're going to take this value and then subtract 5 from it. It is now 2. Where do we go next? Nope, not line 3. We go back to line 4 first. Okay, so we go back to line 4 first. Okay, to evaluate. Oh, not this particular cell. Okay, yeah, there we go. Get rid of this. So we go back to line 4 first. We evaluate or reevaluate the condition x is greater than or equal to 5. We have to know that it is false before we exit the loop. Is that okay? So now where do we go? Hmm? We go back to line 2 right now. Okay, that is correct. Now we go back to line 2. So I'm going to pause here to make sure that everybody understand why we go directly from line 4 all the way back to line 2. Do we have any questions about that? No questions? All right, excellent. So now we go back to line 2. Line 2 is asking x does not equal to 0. That is definitely true because 2 does not equal to 0. And then we go back to line 3. We add 7 to it. Okay, so I'm going to do the same thing. So it would be this value plus 7. And then we go to line 4. which is asking is x greater than or equal to 5. It is true. We go to line 5. Now we compute this value minus 5, which is now 4. Then we still have to go back to line 4 first to indicate that the condition is false, and then we go straight all the way back to line 2 again. So on line 2, we are going to reevaluate, okay, whether x is 0 or not. So now we say x does not equal to 0 is true. So now we go back to, so this is a good time to kind of use this little tool here. So this way I can preserve, oh, not that, the, uh, the mouse button on this keyboard is a little bit finicky, so sometimes it doesn't work the way that I want it to do. But this allows me to scroll the bottom part of the screen without affecting the top part, which is really handy when I only have so many pixels on the screen. The screen is now running in 180 by 720 pixels. So this is also known as the 720p resolution. Your laptop probably has way more pixels than we are looking at the screen here. So you probably did not run into this problem. All right, so we get to line 3. Line 3 is adding 5 to 4 again. Okay. Oh, did I make a mistake? No, I did not. No, I did not make a mistake. We're not adding 5, we're adding 7. Okay, because in my mind, I I thought that we were adding 5 again. We go like, well, that wouldn't make sense. That turns it into an infinite loop. Nope, we're adding 7. There we go. Okay, that makes sense. So now we get to line 4. And then we ask, is x greater than or equal to 5? It is true. Go to line 5. We subtract 5 from 11. Okay, so we take this, subtract 5 from it, and then we ask again. Did I make a mistake? Nope. Okay. Line 4, x is greater than or equal to 5 is still true. Okay, so sometimes it will take 2 iterations, and some other times it will only take 1 iteration. So this time it took 2. So now we have this value minus 5. And you can see AI at work right now. All I did was to put in an equal sign to say that I'm about to enter a formula. And then Google, using Gemini probably as a backend, automatically recognized the pattern from the cells before, and it prompted me. It's like, oh, okay, I see there's a pattern here. Do you want to subtract 5 from your B19? And the answer is yes, that's exactly what I wanted to do. I call this slightly creepy, okay, because this is without me prompting the tool and say, hey, notice any patterns here, help me simplify my task. Nope, I did not ask at all. Okay, it did this all on its own. Cool. Okay, kind of cool, but also creepy at the same time. All right, so now we can say x is greater than or equal to 5 is false. We go back to line 2 again, and you can see how this goes, right? It is rather long. Okay, so now, but I'm gonna finish this, okay, because I don't want to finish only one half of this and go like, okay, now you guys know what this is going to do. So x does not equal to 2. 0 is true. We go to line 3, and uh, it is that smart. Okay, so what can I say? It doesn't quite know how to do this part here, because it doesn't understand because it cannot see the algorithm. Okay, if it could see the algorithm, I can see that potentially it may be able to even prompt, oh, okay, you want to say x is greater than or equal to 5 is true. Okay, but remember, the algorithm is only displayed on this computer as a bitmap right now. So, Google Sheets actually has no access to the algorithm itself, and as a result, there's no way it can find the structure of the algorithm. Okay, so now we have to do it by hand. Okay, x is greater than or equal to 5 is true. We go to line 5 again. We subtract. I'm not sure what you're thinking, yeah, but I'm thinking this is actually kind of interesting. Okay, this is now false. We go back to line 2, and then we ask x does not equal to 0. It is true. We go to line 3. It knows that we are supposed to add 7 to it. So this actually makes my task a little bit easier. So x is greater than or equal to 5 is true. On line 5, subtract 5 from it. Go back to line 4. X is still greater than or equal to 5, right? And then we go to line 5, subtract 5 again. Now it is 0. So where do we go now? We go back to line 4. So we go back to line 4. Oops, that was my bad. I used the wrong key on the keyboard. X is greater than or equal to 5 is now false. Is false. So now where do we go? Line 2. Very good. Okay, so we go back to line 2. X does not equal to 0 is also false because x does equal to 0 at this point. And then where do we go? Post. Yep, this is exactly where we go to post. Very good. So it was kind of long as a trace. Okay, some people might have thought about, hey, did tech just tricked us and gave us an infinite loop? No, it was not an infinite loop. Okay, it just inches closer to 0 in a very weird way, but it got there eventually. Are we good so far with this trace? Yes? Okay, excellent. All right. Do we have any specific questions about this trace? No questions? All right. Well, if there are no questions, because I wanted to wait long enough for people to actually respond, because I know people who ask me, "Hey, Tech, do you have any questions?" And then 2 seconds later, that person continued the conversation, and it would usually take me more than 2 seconds to formulate a question. So I just wanted to make sure that I gave you guys enough time to formulate a question and ask it. So are we good? All right. I see confirmation. I see nods. Okay, very good. All right, so we are technically done with control structures. In other words, at this point of time, we are pretty much done with this entire Canvas module, which is named control structures, and we are moving on to arrays, which we which I got into a little bit on Monday. So once again, if you have not watched the recording on Monday, it would be a good idea to do it. Okay, it would be a very good idea to watch it as soon as you have time to do it, because this is supposed to be a hybrid class where we have one lecture or one half of the lectures is in person and then the other half is online. And since I do not know how to conduct lectures online in an asynchronous mode, so I just go like, okay, we'll use Monday at exactly the same time, exactly the same place. I will do the actual lecture, but I'll have it recorded. So if people cannot make it, they can still watch it. So that's the whole idea, which I have already talked about in previous classes. All right, so now we go into arrays. On Monday, we kind of talked about it a little bit, about the concept. So today, what we'll do is we're actually going to dive into the whole thing about arrays. The reason was already explained on Monday, so that's not the portion that I'm going to repeat today. So we're going to go straight to section 3. Okay. So in section 3, it basically describes an array like a box, okay, which I also showed on Monday. There was a picture. So let me switch to my tablet. And to do that, I have to make sure that it is on the right network. And it is not on the right network right now because it's not powering up the router. Okay. All right. So this is going to take a little bit of time, but I'll draw it on the whiteboard, instead. Um, we go. So an array is like a box, okay? It is a container. So when you imagine an array, it is a box. The box has a name, okay? So the array has a name, and I typically just use lowercase a, for array, okay? But you can use any identifier for the name of the box. So I'm just going to call this box A. So inside the box, you can have multiple items, okay? Because it's a container, it can contain multiple items inside the box. So each thing inside the box, at least for the time being, we'll just assume that everything in this box here is an integer, okay? It just stores an integer value. And let's just say that we have three of those, okay? So we'll look at these as coffee mugs or glasses inside the box because each one is its own container. How much fluid is inside each cup is independent to the other cups. Are we good so far? All right. So each container inside the box here, so I'm going to give you a X-ray view of the cups here. So each one of these cups inside the box, they don't have names. They have numbers. Okay. In other words, the way that we identify individual glasses inside the box is by the number on the container. The number always starts with zero, and then the one in this case, and the last one, the third cup, is labeled two. So zero, one, two, they are called the indexes of the items inside an array. So are we okay with the concept? Okay, the container itself can have many glasses or coffee mugs inside. The container, the box itself has a name, and then each item inside the box does not have a name, but instead it has a natural number. Not so much an integer, it's a natural number because it can go negative, cannot go negative. So each one has a natural number as its own ID inside the box, and it always has to start with zero, and then you have to number all the subsequent containers using consecutive natural numbers, which means you cannot skip. You cannot go from zero to two. It has to go from zero to one, one to two, and so on. So are those rules kind of understood? Good. Okay, so when we want to access a particular cup, because we want to say, okay, how much fluid, how much liquid or water is in the glass with a number of one in the box of A? That is now referring to syntax, but I don't even bother with B and F in this case because it's rather easy. A bracket one is how we designate this particular container. That is just the syntax. So the way you remember this is the brackets. Okay, most people would be redundantly calling those square brackets, but when you use the word bracket, it is implying that you're using the square one. So the curly ones, okay, they're called braces. The square ones are called brackets, and then the round ones are called parentheses. So each one has its own specific name, and when people say square brackets, they're just being extra explicit that we're referring to the brackets. When they say curly braces, they're just being extra careful to make sure that there's no ambiguation. But the names, the terms, brackets, braces versus parentheses, they are precise enough already to tell you which punctuation mark we are referring to. Are we good so far with that too? Okay, that's kind of more or less a side note in this case, but I still think it is important. Okay, so why is this super duper, helpful when we need to specify algorithms? Well, the thing is, when you use this syntax here, what is between the square bracket? Okay, in other words, this part here, it does not have to be a constant. It can be any expression that evaluates to a natural number that makes sense inside the box. So I'm just going to pause here. Okay, was that sentence understood? Because it is really a key component. It's a key concept of array indexing. The importance has to do with the way you identify a individual container inside the box is can be an expression that returns a natural number, and as long as that natural number is within the range, okay, of the numbers on the coffee mugs in this case, it will still work. That gives you a lot of flexibility when you need to express a method of how to get things done. So are we good with that? Okay. So personally, okay, after having taught this class and many other classes for years, I still think that is one of the most important things to remember about array indexing, okay? Because that is why we can specify, you know, a lot of algorithms is through array indexing. Okay. So with that said, we are going to move on to talk about some algorithms, and then we're going to trace it, okay, so that you can see how we can visualize, when the algorithm works, how it is actually going to work. So you can see this is an algorithm, and the trace is already given here. I'm not going to just read the trace itself. What I'll do is I'm going to copy and paste this into a corner, so just like that, and then we'll go through the trace, you know, live during the class, just so that with every single step of doing that trace, you guys will have an opportunity to ask, so what is happening here? Okay, so we are going to do just that. So the trace is on. Okay, I keep having some issues with clicking the button. So I have to use my left thumb to actually hold on to the mouse button because it's too springy on this keyboard. So now we open it up, make it always on top. Okay, there we go. And move it to the upper right corner. And then we are going to go to the shared folder again and make another. Oh, actually, I don't need to make another one. I can just use the one that we already have. So that would be this one. Yep. So I'm going to name this particular sheet init trace because it is the trace of the initialization of an array. And then we have to go back to the notes because there are a few pieces of information that I need to know in order to perform the trace. So in this case, assume n is the number of elements in array A, and we need to know what n is supposed to start with. And that is not given to you until we get to the trace here. So n is 3. Okay, there we go. All right. So now we go back to the trace, which is here. And then we do the same thing. We have line number. We have n. Okay, so n in this case, or the precondition of n is 3. You have to know n ahead of time because otherwise you cannot compare n to the variable I. So now we also have a variable I, and that one does not need to start with any particular value. And I am just going to make the columns a little bit narrower because we need more columns this time. So now what about array A? Array A is not a single column because there are 3 items inside the array, just like what we see on the whiteboard. So each container inside array A needs its own column because the value of each item inside array A is independent to all of the other items in the same box. So you cannot combine all the elements inside array A into one single column because we have 3 different values to track. Each value is going to need its own column, or each variable is going to need its own column. So A bracket 0, referring to the first item in the array, has a column. A bracket 1 is the next one, and then A bracket 2 is the last one. And then once again, we have a comments column here because we do have a loop and we need to kind of indicate what is happening as we go through the loop. So that is how everything is set up, except I also need to kind of indicate that array A inside array A, none of the items has a particular value because even if they had any specific value, line 3 is going to change everything back to 0. So we are not going to make any assumptions here. So I'll pause a little bit before proceeding with row 3 of the trace, which really is the first line of tracing the algorithm. Do we have any questions about the setup of the columns? Nope. Okay. All right. Excellent. So now we're going to go forward and we go to line 1. Line 1 is super easy. Okay. It is just a simple assignment statement. So we know it is just going to change the value of variable I to 0. No, nothing big there. Line two is a while statement. We just talked about the while statement, and the condition it needs to evaluate is also really simple. Okay, we just want to know whether I as a individual variable is less than n, which is also quote unquote a variable. I said quote unquote because n does not change. Okay, so it is more of a constant, but we can still look at it as a variable that does not change. Okay. So this is true because I is 0, n is 3, 0 is less than 3 is true. So now we move on to line 3. So line 3 is really the whole point of this little demonstration here is we can see the right-hand side of the assignment is super easy. It is just a constant of 0, so that's not a problem. What about the left-hand side? It is not a particular variable. Instead, it is a in square brackets I. So what does that mean? It means go to the box that is labeled A, okay, because you can potentially have many boxes. Go to the one that is labeled A. Look inside the box, okay? Evaluate the expression I. So I, in this case, even though it is just a variable, you consider that to be an expression. In other words, in other situations, it can be I times 3, the whole thing divided by 2, take the square of that, and then divide that also by 14. Okay, it can be complicated. But in this case, it's just I, but it is an expression. Evaluate the expression I, okay? And what would be the value of that expression? It'll be 0 because I actually just has a value of 0 at this point. So A bracket I is now becoming A bracket 0, which means we are changing which column to a 0. So that would be column D. Very good. So that's why column D is changed to a 0 in this case. Okay. And then we go to line 4. Line 4 is a really typical way to increment a counter. So we are just incrementing I from 0 to 1. And then we go back to line 2 because that's the behavior of a while loop. Line 2 says, okay, let's compare I and n again. I is less than n is still true. We go back to line 3. Line 3 is changing variable I from 1 to 2. Let's see, did I make a mistake? Nope. Okay, I made a mistake because we're not changing I yet. Okay, line 3 is finding out, okay, which item in the box am I changing this time? So line 3 is having A bracket I again. In other words, it's the very same line on line 3 as when we traced it on row 5 of the trace. But because I has changed, now it is going to change a different item in the box. What is the value of the expression I? It is now 1 because the value of I has changed to 1. So that means A bracket I is no longer referencing column D. Instead, which column is it referencing now? Column E. Very good. So it is column E that is now getting a value of 0 this time. Line 4, once again, not very exciting. We're just adding 1 to I. I becomes 2. We go back to line 2. I is less than n is true. And we go. We go back to line 3. Okay, I think you guys are getting the hang of this. Which column is getting a 0? Column F. Very good. So column F is the one that is getting a 0 this time. And then we go to line 4 again. I is incremented from 2 to 3. We go back to line 2. We compare those two, it becomes false. And then we are getting to post. Yep. So that is the trace of this particular algorithm. There's no need to take a picture because it is in the reading material. But if you want to take a picture, that's fine too. All right. The most important part is not about what you see or what I have just said. Okay, because let me see. All of that is being recorded. Okay, I just have to double check because sometimes I forget to click the start button. So I would have everything set up except it's not recording anything. It is being recorded. So what you need to write down in your notes are your own thoughts. Okay, are you making all the connections? Okay, things that I did not say, but you have that conversation in your head. That is the part that you need to jot down. Okay. Now, this method does not work for other classes where the professor is not recording everything and posting everything on YouTube. But in this class, you have that luxury. Okay. Now, if you're not sure, okay, should I really write down everything on the projector? You can always ask me, Tech, are we recording? Okay, because if I'm not recording, then you probably need to write everything down. But under normal circumstances, I should be recording everything. Okay, but if I am recording everything, that means you don't have to really busy copying everything down on the projector, and instead you focus on the way that you understand what is happening. Are we good with that? All right, very good. So I can see quite a few people are writing notes. Okay, the reason, okay, I want to digress a little bit to emphasize why writing notes can be important for some people is when you write notes, okay, and you're not just copying whatever is on the whiteboard and you're trying to capture your own voice, your own thoughts, that process is already helping you to not only understand the material, but also to remember the material. When you're listening to me and looking at the screen, okay, and you go like, oh, I get exactly what you're saying, that is involving one particular process in your mind. But when you need to find the words to describe what you have just understood, the connections that you have just made, or the concept that you have just captured, and you want to write it down in your own words on a piece of paper, that involves a separate process. The writing process is not exactly the same as the process of listening to someone, nor the process of reading something. So when you write down something, your brain, your mind, is actually establishing a different pathway to the same material. The more pathway you have in your mind to the same material, the, the more likely you won't forget it, and also the more efficiently you can retrieve that information. So those are the reasons why some people take notes. Okay. Now, does it apply to people who have photographic memory? Maybe not. Okay. Does it apply to people who have to take this class because only on paper they need this class to fulfill the requirement of CISP 360, but those people actually have taken programming classes, from other places, or they have programming experiences already? No, those people do not need to take notes. But for other people, okay, this can be note taking can be a very effective way of quote unquote studying and understanding the material. So I just want to kind of sidetrack a little bit to talk about that. All right. So are we good with the trace of this particular algorithm? Do we have any questions about any rows of this particular trace? Or why we update specific columns at a certain time? Do we have any questions at all before we move on? Okay, I don't see any questions. Okay, nor do I see any sign that people are thinking about asking a question. Okay, but since I'm not a mind reader, I can't really tell for sure. Okay, so if you do have a question, or if you're formulating a question, you cannot quite ask the question yet, you can always raise your hand and go, I'm still thinking about how to ask that question. And I'll give you time to think about how to ask the question. So are we good with that? All right. And I understand some people are very introverted or they're shy and they don't want to ask questions in class. So for those people, you want to write down the question on in your notes. Okay. So you basically go like, okay, question, and then put a circle around it and then write down the actual question. So after the class, you can come to my office hour. Okay. You can try to answer that question yourself after the class. But anyway, you have to remember that you had a question, okay, before you forget about what you have in your mind as a question. All right, so this is the first example. We're going to move on to some additional examples about arrays. So we're going to move on. Okay, you can see this is exactly the same thing, okay, because everything's already captured here. So the next one is how do we search for a particular value in an array? Okay, so this one is a little bit more complicated. I actually try to explain the process of coming up with the algorithm, which you can kind of go through. It is kind of wordy and kind of you know, not very easy to kind of read through. But what I would do instead in this class is to go through this logic here and trace the very final version of this. So we'll go ahead and look at this part here and then just kind of do a trace. Okay, so this is what I'll do. Actually, in this case, I don't want to do a screen capture because it doesn't have line numbers yet. If it doesn't have line numbers yet, I would copy and paste it. Come on, there we go. All right, so we copy and then we can paste it into the spreadsheet here so that we can use the row number. Okay, so we'll call this linear search and then do a paste. Oh, great. It doesn't want to paste it into different lines.